Good day. I'm Martin Gago with Market Radius Research. It's Tuesday, April the 18th. And we've got CEO John Passalacqua of First Phosphate joining us. First Phosphate is focused on extracting and purifying phosphate for the lithium phosphate battery or LFP battery industry. While the market news headlines often focused on the big sexy metals and minerals like lithium, cobalt, nickel, graphite, and the rare earth, there are other elements that are going to be needed as well, like phosphate. Phosphate has been traditionally used in agriculture and phosphoric acid, and this new application in LFP batteries is brand new and very significant. Companies like Canada's Nano One are helping building out those LFP technologies. First Phosphate recently came public with a very large mineral asset strategically located in Quebec. I'm looking forward to learning about First Phosphate's asset, growth strategy, technology roadmap, and how it fits into Quebec and Canada's broad and very ambitious mine-to-motor development strategy for the electric economy. But please remember, this is neither recommendation nor investment advice. We're here to learn about First Phosphate. John, thank you very much for joining us here today. And welcome to the public markets. It hasn't been that long since you came public. Please tell us about First Phosphate and what's going on.
Yeah, hi, Martin. Thank you very much for the invite. Very nice to be with you and your audience. First Phosphate has been public now for about almost 2 months. Like you said, we're a very rare story. We're into a segment that's actually 50% of the batteries that are made there globally. You know, it's not just NMC. NMC's got about 50% of the market share. That's nickel, manganese, and cobalt. But LFP batteries take up about 50% of the marketplace as well. And we're going after a really particular solution, which is that of being able to provide purified phosphoric acid that is then the main element that goes into making LFP cathode active material. That's LFP powder, lithium iron phosphate powder, that goes into lithium iron phosphate batteries. So think of us as kind of maybe almost like the first going into the LFP battery, like lithium was when NMC batteries started. I'll also point out that lithium still does go into lithium iron phosphate batteries. Usually, it's about less than 3/4 or a half of the amount of lithium that goes into a nickel, manganese, cobalt battery will go into a lithium iron phosphate battery, and that's another great advantage there because you can make almost twice the amount of batteries from an LFP battery than from a nickel, manganese, and cobalt battery.
All right.
So would you like me to take you through the presentation now?
Please do.
Okay, great. So, we're phosphate. We're fully focused on the lithium iron phosphate battery. We're the only company in the world that we know of that's fully focused on phosphate and the lithium iron phosphate battery. We plan to vertically integrate, that is from mine source all the way to the production of LFP cathode active material. That's the powder that goes into the battery. And we have 1,500 square kilometers of royalty-free claims in an entire district in the Saguenay-Lac-St-Jean area of Quebec. And this rock here is, the rarest form of phosphate that you will find in the world. It's pure igneous rock. It's low in sulfur and it's low in radioactivity and other harmful elements. And it can make a very large amount of purified phosphoric acid. About 90% of it can be converted into purified phosphoric acid, which is the precursor for the lithium iron phosphate battery. When we look a little bit at, phosphate in the world, which is important to know, 95% of the world's phosphate, these little red dots, is sedimentary phosphate. It's almost like old seabed. And that is good for making a lot of fertilizer, which doesn't require a very high level of purification because the sedimentary deposits have a lot of uranium, cadmium, thorium, and other heavy metals in it. When you want to make LFP battery, you should really use, igneous source, volcanic-based rock, where the phosphate is much purer. So we have 4 main regions of this volcanic rock, a little bit in Africa, but those are almost completely inaccessible. There's some of it in Brazil, but it's used for fertilizer and it's got rare earths in it. And then you've got a little bit here in Russia that's was being exported until, before the war. And then inside of North America, we've got an area here, Saguenay-Lac-St-Jean, with this really rare anorthosite rock. And this is going to be able to, supply all of the needs of the LFP battery here in North America. So when we go on to talking about the LFP battery, right, what's going on here with the LFP battery? Well, these batteries are non-toxic. They have a superior fire safety and they're longer lasting. So what that means is that, the auto manufacturers in North America, Europe, and in Asia are starting to flock to them also because they're, 50 to 66% cheaper, at least their anode cathode active material is, than a nickel, manganese, and cobalt cathode active material. So, the reasons that we feel that we have a competitive advantage is obviously the geographic area. Quebec, Canada is a great mining jurisdiction. Again, the very special rock that we talked about, and the fact that, we can supply the cathode active material, the LFP cathode active material across North America in what is a very environmentally friendly and traceable and ethical fashion, so that, we're fully on the ESG scale. Now, this is a market that is, 10 billion. It's projected to go to 50 billion by 2028. 50% of all the batteries right now are LFP. 90% of it is made in China. And, under the U.S. Inflation Reduction Act, we have to repatriate that back to North America. But then when you look at North America, what's the problem for sourcing these materials? Well, North American phosphate is depleting. Existing reserves are at capacity for fertilizer, and existing sedimentary mines cannot economically produce the same amounts of purified phosphoric acid that you can with igneous rock. So what we're proposing is that the Saguenay-Lac-St-Jean area of Quebec would become, the LFP battery valley of North America, where we would be able to, get all the in situ elements that are necessary for making the LFP battery, produce the LFP powder, and then ship it across North America. We're very lucky in that we have an MOU with the Port of Saguenay. It's a beautiful port area. It's got lots of free space, about 700 hectares of open land where we can build facilities. And then we also have an MOU with the world's largest producer of purified phosphoric acid. That's Prayon Technologies. We've got an offtake agreement with them where they would be taking on some of our unbeneficiated phosphate rock. And then also we have an agreement with them for the technology side of it, where we would be able to process our phosphate concentrate into phosphoric acid with Prayon, and also potentially open a fully fledged purified phosphoric acid plant in Quebec, Canada. And lastly, we're looking at, with Prayon, since they have specialties in making LFP cathode active material, we're looking at potentially working on an LFP cathode active material plant in Quebec as well. Now, if you look at this is really interesting. This is the amount of LFP cathode active material that might be required, as we go down the electrification road. We've projected very conservatively, and this is just for small EVs, that by 2030, we will need about 720,000 tons of LFP cathode active material. And so far, there's only about 35,000 tons that are being projected, and that's through a subsidy program through the U.S. Department of Energy. So as you can see, there's still 95% of this that is for the takings, right? And if you look at that, that becomes almost, an $18 billion business by 2030. So First Phosphate is saying, if we could just gather a 10% market share in this space, that would be, probably a $2 billion sales revenue, which, obviously gets a multiple in the capital markets. And right now we're just sitting at a little itty bitty $30 million market cap. So obviously we have to walk before we can run, but the blue sky and the potential is very large.
John, just going back to that slide, I just want to sort of highlight a couple of things. In the U.S. IRA, to get like your subsidies for cars and so forth, you need to have a certain amount of battery materials coming out of the North American market. Canada is part of that trade zone, I believe. And even just yesterday, I was reading a bunch of companies, their cars were sort of excluded off the tax rebate plan because they didn't have enough North American battery metals and elements in there. So the LFP market right now is coming largely from China. Yours would clearly be part of the IRA inclusion as being rebate or eligible, correct?
Yeah, that's exactly it, Martin. You might have heard also in the news, there was a talks about Ford and even a rumor about Tesla working with a CATL, which is the big Chinese company that makes LFP cathode, makes LFP battery cells. And so, yes, they would need to source, even if that happened, they would need to source that LFP powder from somewhere. And I guess they were planning to source that from China, because right now there is no production of LFP in North America. It all comes from China. So yes, it's very important for this project like First Phosphate to take hold. And that's what we've been aiming at since the beginning.
All right. And where currently, like from China, where do they get their phosphate? Is it coming from sort of those more agricultural sources, so that this we need for, and they just have to spend more money and more bad stuff to get it to a purified form, or what is the current supply of phosphate from?
So what I'll do is I'll flip down to this chart here.
Sorry.
Oh, that's fine. there's two ways of making phosphate in the world. There's what's called the thermal process, and then there's what's called the wet process. So the rest of the world uses the wet process. Basically, almost only in China do they still use the thermal process. It's a very environmentally polluting process. What they do is they take very low-grade phosphate ores that are kind of like the sedimentary fertilizer-based ones, and they would put them in these big furnaces, that are heated by coal, and they crack the phosphate. And that way they get a large amount of purified phosphoric acid from lower grade ores. So I guess, if you look at it, in a practical Machiavellian sense, it achieves the objective. But, what it does to the environment is terrifying. And, those are the batteries that are going into our electric vehicles here in North America. So that's an eye opener. Are we really solving the problem with these batteries that are coming from China? Are we really, moving towards electrification? Does it make sense to move towards electrification to save the planet from emissions? But then, we're doing the planet injustice when we're actually making those batteries. So that obviously most people would agree with us on that and say, like, this is just an X, right? Like, this process is going to have to go in China and also anywhere else in the world. So when you come back to North America and you think about how do you make phosphate in North America? Well, right now, what we do in the rest of the world is we treat phosphate rock with sulfuric acid, and it creates gypsum slag, which is radioactive because it's made from sedimentary deposit. That's when you use sedimentary deposit, and you only create a small amount of purified phosphoric acid. So that's why the Chinese method here is so, I guess, taunting, right? Because they can take these low grade ores. Instead of making a small amount of purified phosphoric acid, they can make a lot of it, but it's polluting. So what the solution really is the same process is used here. You would take sulfuric acid, you would take igneous rock, which is a volcanic rock that we have in Saguenay, Quebec, use Preon technology. And what ends up happening is you recover 90% of that to purified phosphoric acid, and the gypsum is recyclable. And the reason the gypsum is recyclable is because the gypsum doesn't have the radioactivity that the sedimentary gypsum has. So what we end up doing with this process here is we end up creating the same amount of phosphoric acid as they do here in China, but it's obviously in a circular fashion, and it's fully environmentally friendly. If you look at what happens in this process, for instance, this is what you'll find in Florida, North Carolina, and South Carolina. These are the gypsum slag piles that are produced, and they cannot be recycled. They just sit in there in the environment to perpetuity. Sometimes these dikes, they break. The liners under here break. There's sinkholes that develop. And a few times during the hurricane, some of these have been washed out into the Gulf of Mexico. So, there's been high, levels of radioactivity. Farmland has been, pretty much nuked. And there's been lawsuits around it too. So it's very hard to get new mines approved in that area of the world, that being the southeastern United States, because of this. But with the igneous process and the Preon process, what you end up doing is you create plaster out of the gypsum, because it's not radioactive. Like if you use this plaster here in your house, you'd have a radioactive house. But here, since there's no trace elements in our phosphate, we can fully recycle this and fully have circular economy. So what we do with this process is, we definitely beat out this process, and we beat out this process too. And what you have for battery is something that's really exciting and, fully environmentally friendly and recyclable. And it meets all the aims of electrification. That's why we're building at First Phosphate, the process for the future.
Excellent. Thank you.
So what I'll do is I'll just skip back up to here.
Yeah.
Oops, where we were talking about. Yeah, we were here. Oops. We already talked about, market potential, but think about what I just showed you, right? It's not only the market potential of this, but it's the market potential of this done properly to an ESG scale, and where, we feel comfortable, and there's a proper supply chain around this. Anybody could come up, to the mine or the production sites, and they would feel comfortable walking through there, knowing that, there's all environmentally sound circular methods being applied, or at least we're going to the maximum that we can to create this product properly, right? So what I just showed you there was just 25% of just small EVs, but there's a lot of other aspects to LFP as well, which is large scale energy storage, small mobility. There's also trucks and vans and all that kind of stuff. So what we showed you here is probably like might be a fifth of what the actual demand is for LFP. So think about that. Think about how massive this industry could truly be. And this is what we're doing here at the Port of Saguenay. This is our idea for the ecosystem of the LFP battery in North America. So it's like, we would like to concentrate here on this part here, the upstream and the midstream, being that, we would extract ore from the ground at about 5 to 10%. And then at the mine site, you concentrate it. So you get to about, 95, 96% apatite, which is about 40.25% phosphate inside of that. We've already proven out the mineralogy on that. And then after that, we send it through the Preon process. We create purified phosphoric acid. And after that, we would create LFP cathode active material with some of our partners. So that's exactly where we would stop after. We would have this powder that then goes to those who are making the battery cells and the battery packs. Like we talked about, potential agreements between Ford, or the discussions between Ford, Tesla, and CATL. So we'd be able to provide in that powder that it really is the start of everything. Like once you've got the powder created, the rest of this is, I wouldn't say it's easier, but I would say that the processes exist, but it's just creating that powder that's really important. So we want to really be, the people who get our hands dirty and get really the important product to market. This is a little bit about our deposit. So, we got a 43-101 on this property. We're now moving it into PEA. PEA should be ready by the end of this year. We're 140 kilometers from the deep sea port. And, we've got a very good workforce in the area. We've got a deep sea port. It would help us for our offtake to Belgium on the phosphate concentrate. This can operate 365 days a year. These are mining roads. They're right by the property. We can operate with, 52-ton trucks. We don't need to create any new ports. We don't need to create any new infrastructure. We just work with what's there and existing. We keep our mine costs down, our CapEx down, so we can focus our CapEx on, making LFP cathode active material. This is kind of a little bit about the deposit. You can see that it's on surface. There's still a lot more drilling that can be done. It's 49 million tons in the ground already. And it's got important secondary recoveries of titanium and iron as well. This was the property that I just showed you, but we've also gone out and we've covered off the whole area. We covered off all these other areas where we found phosphate, and we're starting to really do surface sampling on all of them. And right here at Saguenay-Lac-St-Jean, which is 75 kilometers from the deep sea port, this property, Lac-Lorignel, the flagship being 140 kilometers from the deep sea port. This is 75 kilometers from the deep sea port. So it's got, extreme infrastructure advantage. And it's also got the highest phosphate that's ever been found in the area. We found about 8 to 10% phosphate so far. We're still drilling, but it's looking exceptional on these 4,200 meters that we've done. We found good grades of about, in some cases up to 8 to 10% phosphate. I mean, this area here is 5.2% phosphate is still good. And up here, another company's got about 6.7 to 6.9% phosphate. So this being at, 8 to 10% phosphate and at, 75 kilometers from the port is extremely attractive. We're also kind of at the end of where civilization stops, and we're right near, a nice mining community and forestry community that's very welcoming to the project. They want to see the development. They want the new jobs in the area. So we're quite excited to continue to drill and develop Saguenay-Lac-St-Jean.
Can you, go back 2 slides to the resource estimate one? Okay, so how large is, like, the premise is you've got a resource right now, you're going to be coming out with a PEA later this year, and then you've got blue sky with a very large property, a package with some good-looking rocks there. So tell us, how large is this current resource estimate? Tell us a little bit about this.
Yeah, so right now it's 49 million tons between inferred and indicated. That's of P2O5 phosphate at 5 and 5.1%, and it's also got iron oxide at 23-24%, and it's got titanium at 4.2%. What's interesting, and we've done our mineralogy on this, so we can get this out. We can get this up to about 40.25%. The phosphate, that is. And then also with the secondary recoveries, we get a recovery of iron and a recovery of titanium, all part of the same process, which can already be sold off as well. So it almost gives us a negative cost on the phosphate. We're still working through those numbers. Those numbers will come out in the PEA. So, I have to be careful what I say, but it's looking really positive on these secondary recoveries, really driving down the costs of the primary recovery, which is the phosphate.
And so in a phosphate ore, is it like a big sort of homogeneous kind of blob, like a porphyry type of thing, or what? And you said it's at surface level, so it'd be presumably kind of an open pit structure?
Yeah, that's a good question, Martin. So most of these are open pit mines. You got to remember, it trades by the ton, right? So it's almost like a gravel. It's not as much as a gravel, but it's big quantities, and they're usually in like layers or lentils. So you can have it in different layers. and usually there will be like various layers in the same deposit. This one is quite uniform, but there already is a couple layers, 1, 2, 3 layers, as you can see, and another one down here. So there's a lot more drilling that can be done around it as well. But yeah, usually if you don't find it at surface, it's not really worth looking for it anywhere else. You start the surface sample. Once you find the surface samples, then you start drilling for it.
Okay, so big tonnage stuff. Excellent. All right, thank you.
Yeah, that's why it's also important to be right near infrastructure, right? It's because of the tonnage that's involved.
Yeah.
Okay, so here I was just getting into sort of, our catalyst for this year. We're looking to build out our beneficiation pilot plant, which, is the next step, that when you take the ore out of the ground at 5 to 10% and you concentrate it up to 40.25%, like our mineralogy has shown, which is almost, get pretty close to theoretical purity. So we're doing that beneficiation pilot plant. Then we'll be sending that material over to our partner to create some purified phosphoric acid that's at Crayon in Belgium. And then after that, we take that purified phosphoric acid, and we already have another partner, IPL, out of the UK, that would be using it to make some LFP cathode active material, which would help to support the premise for, making our own cathode active material pilot plant very soon. And then another catalyst is, we're going to continue to drill at Bégin-La-Marche. That's a spectacular development that we showed you very close to the deep sea port. And then, of course, we're moving into PEA at La Coloniale.
So on your supply chain, the phosphate rock that you would dig up would get shipped over to Belgium, where they would process it there, or is that be kind of preliminary steps until sort of volumes are set up, and then that manufacturing or processing would come back to Canada?
Yeah, so a really good point there, Martin. So, you take the ore out of the ground at about 5 to 10%. And then what ends up happening is at the mine site, it's concentrated up to 40.25%, right? That's okay. That's about pretty close to the theoretical max, which is 42%. And so that's called beneficiated phosphate rock or phosphate concentrate. And then that would be shipped to Belgium, yes. And they would use it.
At the beneficiation stage, is that where the titanium oxide and the iron is separated from the ore?
Correct, yes.
Okay.
What happens is, because the titanium and the iron are magnetic, they use magnets to pull that out first, and then whatever's left over, they do a flotation process. And I'll add also that's a completely solventless recovery, which is great.
Yeah.
And so there's no chemicals involved like you have with some of the other materials. And then that would be sent to Belgium, yes, where it's then processed into purified phosphoric acid. And once our quantities get big enough that it justifies, creating a purified phosphoric acid plant in North America, then we would turn around and with Crayon's technology, we would build that kind of a plant. But obviously, it's a lot of capex. It's not something you want to get involved in right away. You don't have to.
Yeah, that makes sense. Okay.
All right. So, coming down here, I guess, our main, our main strong points behind the company are, very strong management, strong set of local and international partners. And we have a manageable mine size near infrastructure, right? And we have capex that's aimed at value add. We have important secondary recoveries. We have in situ management of most of the materials, which is important. And we have a rare opportunity once in a lifetime to go from mine all the way to LFP cathode active material, and lots of blue sky potential as well. Right now, we've got a very tight share structure, about 75% owned by friends, family, management, associates, insiders. $34 million market cap and 48 million shares outstanding. There's myself. I'm more of a technology person, so I'm always looking downstream. I'm very lucky to have with us Peter Kent, who was the ex-minister of the environment under the Harper government. He's a great politician, works on both sides of the aisle very, very, very comfortably, has been in media for a number of years, and just a great spokesperson and mentor for the company. He's our president. And I'll just give you guys a little bit of a background here on the world of phosphate. Now that we've talked about what is first phosphate, if we look at the world of phosphate, so the biggest share of phosphate is really found in Morocco, and all the other countries in the world are really peaking in phosphate. They have no more than 10, 20, 30 years of phosphate left. That becomes problematic, right? Because phosphate's still at 90% of it is still used in agriculture, right? So you've got Morocco that exports to Europe, exports to North America, South America, Indian subcontinent, and now even starting to export to China because they've got restrictions on export. And if you look at just phosphate from kind of 1960s until now, I mean, this is how much we've used, and to support world population growth and to continue to support ourselves population-wise, this is how much phosphate we need to produce. So what I like a lot about the story is a story around phosphate, Martin, is that, there's a backdrop on it, right? If something happened that, battery technologies changed, there would always be a need for it in agriculture. And so, that kind of gives us a little bit of a backdrop. With lithium and graphene, it's not really the same thing, right? If there was a shock there to the battery industry, I don't know what you would do with it all. I don't know how many pencils or hockey sticks you can make out of the graphite and the lithium. I don't know what you do with it, but at least here we're covered by agriculture, right? And already, if we look here, the price of phosphate rock just keeps going up. It's kind of sitting up here now. It's even gone up during the recession. And, the problem is obviously in North America, we just don't produce as much of it anymore. And we're at a dying mine life. Like we might be done here in I don't know, 20 years.
And so just to state the obvious, what you're referring to is if for whatever reason, the LFP battery market, something happens to it, you can still mine it and then sell it to the agriculture market. And there's sort of, as long as there are people on Earth and we're growing stuff, there's a never-ending need for phosphate there. So that's your plan B if something else would happen.
Yeah, I mean, we're 100% focused on the lithium iron phosphate battery. We see that, that's a trend that's going to go on here until, 2040. But yeah, there is a backdrop of fertilizer, but, we're into making purified phosphoric acid. So purified phosphoric acid is very valuable in and of itself for a number of different industrial applications, which I'll show you as we advance as well. But yeah, there's a strong demand for phosphates, purified phosphoric acid, irrespective of LFP battery. Well, what's going to happen with LFP battery? Now that everybody's getting involved, it's going to requires more phosphate, right? So it just puts more pressure on phosphate for food, which is not necessarily a good thing. And that's why we're trying to bring on a mine like ours, Martin, so that it doesn't compete with food, right?
Yeah.
So here you've got all the major manufacturers, in the world of EVs. They've all moved partially or fully to LFP, but it's not only that. It's large scale commercial transportation and large scale energy as well. And again, the reason is non-toxic, fire safety, and it's lower cost, right? The LFP cathode active material is 50 to 66% cheaper than the NMC equivalent.
Yeah. And I guess going back to I've often heard sort of arguments about, okay, which is going to be the battery technology that wins? And I've always said, you know what? There's for NMC batteries, that has, I believe, a higher energy density to it. And LFP has a lower cost and you can cycle it more times and there are a lot of benefits. So there's going to be cases for each type of battery. There's not going to be one battery technology out there. And it sure seems like LFP has a lot of positive attributes that it'll make it a player in that market.
Yeah, exactly. And, also what we have here is, for the low and medium range vehicles, that's where LFP really shines. It's got a little bit less range than the NMC. But I mean, for what is city driving, going to work, going to school, doing groceries, picking up kids, I mean, it's the battery of choice. It'll run all the small to medium sort of cars, and it'll get the cost down, the cost that you need to get down for mass adoption. And that's exactly what you see happening right now with Tesla moving to the battery for its its entry level models, just to get the price down and to really push mass adoption. But for the higher end uses, you'll always have the NMC, at least for now. So it's kind of a good marriage between the two battery types, right? The LFP and the NMC.
Yep.
But again, all of this is made in China. Here's the professor that follows us at Queen's University, who also did a big ESG study on our property, and says that, this might qualify as the first ever phosphate mine that's on the ESG scale, because no phosphate mine is on the ESG scale because they all use sedimentary rock. But this could be on the ESG scale, and it could sort of help in not competing with food, and it could allow for the creation of a lot of purified phosphoric acid, which is desperately needed for this LFP battery. So it's a great solution to not put pressure on food and to allow the LFP battery to get what it needs, which is the really high purified phosphoric acid. Here's a little bit of, kind of the same thing with the phosphate rock, right? The purified phosphoric acid and the MgA, which is the fertilizer grade acid, it's been going down since the year 2000 in North America, right? So we're creating less and less of it, but we're going to need more and more of it for the LFP batteries, especially this PPA. So, what gives? Something's got to give. And that's where first phosphate comes in to create this purified phosphoric acid and to eventually put it into LFP cathode active material. This is a really good primer here. It's on our website. It's on the first page if somebody wants to read it, understand what the shocks are that are coming. Basically, you can kind of see purified phosphoric acid It's going to go on a hockey stick, kind of like the way lithium did, because it's just going to come in short supply as battery necessity requires it, and it's already starting. This is a little bit we explain here. So 82% they say of phosphate gets purified up to merchant grade phosphoric acid, and it goes into fertilizer. Then another 7% or so goes into animal feeds, and it's just about 10% that goes into these higher applications, purified phosphoric acid for food. You'll find it in a Coca-Cola can, electronics, LFP battery, industrial, pharma, water, fire safety. And this is where the squeeze is going to be, just on this 10% that requires purified phosphoric acid. And it requires a lot of processing and a lot of capex in order to get there. We discussed this slide already, so we don't need to get into it. The difference between phosphate and how it's made in China and how it's made in the rest of the world, and the environmental consequences. So obviously we're here, we're in the circular economy, we're on the green side. When you look at purified phosphoric acid, right, that goes into the LFP battery, it's about 28% of the component of the LFP battery. Then there's another part called iron sulfate. And iron sulfate, you get it from the purification of steel or titanium. And as you know, we've got a secondary recovery of titanium on our property. So what we would do is we would purify that titanium in order to get the iron sulfate byproduct to be able to make the battery. So we'll have like 90% of the in situ materials together in one spot to be able to make the LFP battery. We'll just obviously be missing the lithium, which would come through acquisition or contract with somebody. There are two ways to make LFP cathode active material. This is a traditional method, also known as the solid state method, or they call it the Chinese method. It involves a series of crystallizations until you can create LFP, but it creates a bland form of LFP. What they're really starting to experiment with, mostly in the Western world, is sort of a wet method, a hydrothermal method, where they can control a lot of the elements that go into making the LFP, like temperature, porosity, time, pressure, and they can come up with some good results, different results, which we need in North America to meet some of the challenges of low or very high temperatures. But what this implies is in situ wet materials, and in situ wet materials work well when you're in a lab, but when you're going to make this stuff, like out of pilot scale, and you go into the real world, to get these in situ materials all in one spot is very difficult, and they don't transport well. So that's what we're trying to do at the Port of Saguenay, is bring all the materials together in one spot. So this is, obviously our board and our management, all very serious and experienced executives. We've got a very strong advisory board as well, leading expert Pierre Poufal in the world of phosphate. Yves Caprara has been, he's been CEO of Crayon, who's our partner for over 12 years. He knows that side of the business well. We've got Bernard Laplante, who was, founded another company just to the north of us, Iron Phosphate, that is, still waiting to get out of the ground. So he's with us and helping us, on best practices. And we just have a really excellent team. We're the only company in the world that is, into high purity igneous rock, LFP battery focused 100%, and a secure North American supply source. Most of the other companies are into sedimentary deposit, or they're not LFP focused, or they're not in North America. So, with that kind of concludes it, and gladly take any questions.
All right. That's excellent. Could you just go back to your the milestones catalyst for this year? There we go. Yeah. Okay. So we've done Q1 2023. So in Q2, the check marks, are those things you've actually already accomplished? So you've accomplished some of your Q3 goals, or? Yeah,
we're ahead in some aspects, 3, 6, and even 9 months. We right now we're finalizing on our pilot plant. So that'll be ready. We're preparing to send a sample to create purified phosphoric acid. We're working on a number of local community partnerships. We just announced one the other day with the 2 regions of Quebec in which our properties are located. Have given us, major project status. They want us to work very closely with them on, building a proper project, a project that, looks at, the most local impacts that are possible, working with local businesses. So that's really good. That's a good sign of acceptability, and it just helps us to, nudge through the process in a way that it is understood and in a way that will, will land with, good acceptability and great results for all sides.
All right. And your existing property with the resource estimate and a PEA coming out later this year, that's going to get you going. Like, that is a project all on its own. The blue sky is literally kind of blue sky. You can make this project, this property much larger and so forth. But it's not really necessary to make your existing resource viable. Yeah,
correct. I mean, we see a very long future, Martin, in the igneous rock, and also we're not looking to bring out massive tonnages and massive capexes and big spends on mines. So we're more of the opinion that you go for a smaller mine, less local impacts, closer to infrastructure, less capex. And then, when that mine's done, then you look at doing another one. So, our mine size at Lac-St-Jean might be, up to 15 years.
Okay.
But it's much smaller than anything else that's been conceived in the area. And so it makes feasibility a lot easier.
Yeah, that makes a ton of sense. And then you sort of more manageable bites going forward. I know you don't have your PEA out right now, but can you give sort of just a ballpark number and just say no if it's too far offside of like what is kind of the scale of the capex of a project, like would be like an order of magnitude? Can you give some kind of indication on that, or is that too much to say?
Yeah, I mean, so we're not really able to say too much outside of, a PEA. It's really got to be in a PEA before you can state it publicly. However, I just point people to, a general mine, like any mine in Canada that you got to get out of the ground and have a concentration plant, right? You're looking at about, $400-500 million or so. But again, that's a broad range, and that's just, would apply to any real mining project. As we get here into our PEA, that will be much more calculated.
For sure. Okay, that makes sense, and that's sort of a good scope of to have that on. All right. Okay, so I got a question here from the audience, and any other questions, please throw them up here. Given the nascent state of LFP cathode manufacturing in North America, with only a few companies publicly planning to produce it, do you think that partnerships and discussions with those companies make sense? Why or why not? And are you having any of these conversations? And I've mentioned the company before. Nano One comes to mind particularly on the cathode side. So a lot of questions there. I guess what is the state of your partnerships discussions?
Yeah, so I would just say one thing. Obviously, we're a publicly traded company, and so are some of the other ones. So those kind of discussions really, they're material, and they cannot really be spoken about. But what I will tell you in general is that you're right. It's a very small industry. There are for the time being few players in there. And I can say that when you go to a conference, everybody's there, everybody knows each other. There's all kinds of collegial discussions that take place. And what's really nice, I think, about the LFP battery ecosystems that's developing in North America is that all the companies and everybody, we really need each other. And it's actually the governments that are pushing us to, try to work together, right? Because there's a lot to build. There's few companies, there's limited resources, and there's a really big blue sky out there for everybody. So yeah, no, we feel friendly with all the companies in the space, and we're active proponents of everybody working together. Sure, sometimes things can get slightly competitive, but I think there's just such a much bigger pie out there for the whole industry that working together is what's important. And the other thing I would focus you on is when we discussed this, right? We discussed these methods down here of making LFP, right? And we said that whoever ends up making LFP, which is all those groups that you mentioned, they're going to need access to these components, right? They'll need access to lithium, to iron sulfate, and to purified phosphoric acid. And we're kind of the opinion that there's a lot of companies in this group that are making the LFP process. We're not that interested in the LFP process. We're really interested in having all of them succeed, because we see ourselves as the provider of materials for that process. Obviously, we plan to make the LFP cathode active material ourselves or in partnership with any of these other groups or multiple ones of these groups. But we think that the real solution is the solution that brings the materials to the table. So we're kind of agnostic to what the winning technology ends up being. And we hope they all win, and we want to work with all of them, if that makes any sense to him.
Yeah, you're not picking winners. You're going to work with everyone. You're a key ingredient, and that's a great opportunity.
Exactly.
Could you discuss I think an excellent location in Quebec, both like as mining. It's a great mining jurisdiction as well. It's a big strategic initiative of Quebec to be in the heart of the battery industry. What sort of support are you getting, either like on the regulatory side or financial or advisory type stuff? Can you tell us a bit about your experience operating in Quebec?
Yeah, so I mean, I'm very comfortable in Quebec. I mean, I'm a French speaker. I've spent a lot of time in Quebec. I really like the area here in Saguenay, Quebec. It's a beautiful area. It's very pristine environmental area as well. It's got a great workforce. It's also got industry. It's a great testament to how industry and environment can live together, and humanity lives together, because they've had Alcan, Rio Tinto in there for over 100 years. Now the other good thing is, yes, Quebec is very supportive of their industry. For instance, here at the deep sea port of Saguenay, the Quebec government announced just 2 weeks ago that they would be putting in about $105 million into retrofitting the services at the port. That means, bringing in electricity, gas, water, building a conveyor belt, and upgrading the docks and all that kind of stuff. So they're very supportive of their industry. And what's really important too about the port of Saguenay is, Montreal port is very full. Bécancour, which is the other battery valley, that's getting pretty full, or commitments are full. And even Quebec City port is getting full. So really, we see a big impetus here to develop something at the port of Saguenay. And we're one of the first players, if not the first player, in there, at least from the cathode active material side for LFP. So that's why we have no problem, kind of defining this ourselves as LFP cathode, active material valley of North America. We find the Quebec institutions are very helpful. I mean, Quebec's got a great battery strategy. They kind of treat it like a mission almost, right? So it's really good to work in there when you speak with the politicians or whoever you speak with. Everybody's very attuned to batteries in Quebec. So yeah, probably the best jurisdiction I've heard from a lot of people in terms of North America.
Yeah, and then Canada is getting its act together with the recent budget and getting in line with the U.S. IRA program to make it competitive as well. So we're a few steps behind, but it looks like Canada is, and especially Quebec, is getting very good plans in place.
Correct.
Question here. Have you done any rough analysis of the integrated cost savings available from having most of the raw materials outside of lithium coming from one mine versus manufacturers that may be at a larger scale, but have more transportation and less integrated logistics?
Sorry, can you repeat that? I'm trying to understand it a little bit better.
Yeah, there is a lot in there. Have you done rough analysis of the integrated cost savings available from having most of the raw materials outside of lithium coming from one mine versus those manufacturers that may have larger scale, but more transport and less integrated costs? I think what they're asking is in regards to the battery manufacturer themselves, where they could get numerous inputs from you as opposed to a more diverse supply chain.
Yeah, so that's actually a really good question. And, what you really need to understand there is that there really aren't too many sources of this stuff. When you come down to, making the LFP battery, which we have here, this iron sulfate is almost inexistent in North America because it comes off the processing of steel and titanium, which is done mostly with hydrochloric acid in North America. We're going to go back to using sulfuric acid, but, in a proper way so that we get the iron sulfate, and that's all going to be in situ. And the iron sulfate is really a byproduct of our titanium processing. So for us, yes, of course, we almost get it for free, right? And we get it in situ. You don't have to transport it. Purified phosphoric acid does not transport very well at all. You need very special vessels to do it. You can transport a little bit of it, but not a lot of it. Contamination risk is high. And when it gets to the other place to where you need to have it, the problem is you need to store it, right? And you need to store it without contaminants, and it's a specialty. So what we're finding is a lot of these companies that we were talking about before, when they come out of the lab and they need to get into real life and they need to make things on scale, a lot of them are starting to come to us because there really isn't anywhere else to do this. And that's why we're defining Saguenay-Lac-St-Jean as the LFP battery valley of North America, because potentially we'll have all of these elements available in one spot, done properly, ready to go into the production systems. So it might really come down to the fact that the only place that you can go to in North America to have all the in situ materials ready to make LFP cathode active material, properly vetted, ready to go, clean out of industrial processes, could be the Saguenay-Lac-St-Jean area of Quebec. And that's what we're trying to really focus on at First Phosphate, because we think that's the winning strategy. We see a lot of these other companies coming out of the labs and just don't know where to go for materials, and it's impossible to source them, right? And that blows up the cost. But you're right, having all this material locally and thinking of the plan, that's really what we're solving for. We're solving really for this issue here, right? If you read this little piece, is like a manifesto done by Yves Caprar, the ex-CEO of Prayon, our advisor. He talks about all these supply pressures and how it would be almost impossible to get all these products in one spot to be able to make LFP cathode active material. So we took that really strongly, that message, and that's what we're doing. We're trying to get it all into one spot. I hope that answers the question. And yes, that will drive down costs, and yes, it will be environmentally friendly, and what it'll also reduce is the ability of failure, right? Because when you're going into these batteries for the automobile manufacturers, it's a process called just in time, right? They want everything done to a certain spec and that it all shows up at a certain time, and you need real reliability, and you can't have that unless you've got all your materials ready in one spot. So that's what we're trying to do.
Yeah, we learned that through COVID. Having efficient supply chains is great, but they're very fragile if something puts a wrench into the whole system. All right, question here. You've got a technology partnership with Integrals Power. Talk about what led to that partnership and what they bring with their LFP cathode technology.
Yeah, so Integrals Power is it's a company similar to a number of them out there that are working on the hydrothermal method of making LFP cathode active material. They kind of situate in here along with some of the other companies that were mentioned during our our presentation. And like I said, we don't really want to take on the risk of any of those companies. We did a little partnership with Integrals Power because they seem to have a really interesting technology. We were able to get it in early enough, and they're going to be working to homogenize our phosphate to their process, our iron sulfate to their process, and they will be looking to use all of our products to make their LFP cathode active material. And in fact, they realize already the benefits of maybe co-locating beside us at the Port of Saguenay. So they're almost like a little test model, a little test pilot for what I think could be a number of other companies in the space similar to them that would come and do the same with us at the Port of Saguenay. So, and they have a really nice method. They're looking to make, LFP that can really resist the test of temperature, right? High or low temperature. I've been to their laboratories. I've seen the scientists. I've seen the powder. They're going into pilot scale right now. Just like everybody else in that space, we really want it to work out for them and for everybody else. And for us, it's a good small investment for us. It keeps us close to the space, and it allows us to get our product validated through their processes, right?
All right. That's great. I think we covered a lot of material here. Is there anything as we wrap this up you'd like to highlight before we close things off?
I know, just we plan to be an open and accessible company. We plan to be there for shareholders. We plan to communicate, and there's never any question that's too silly. Feel free to engage with us. Feel free to watch our story. As it develops. We're a company that's very active on various levels because we're looking to become fully integrated, and we think that's where the holy grail is, and that's where the proof and the perfection of the supply chain is to have it fully integrated. It's a lot of work. We're going to have a lot of partners as we go along, and we're really happy to make this happen and be in such a privileged spot in the supply chain in North America. And we ask for your attention as investors, investor support, and keep it coming, keep asking questions.
All right. And over let's say the next 3 to 6 months or so, what kind of news flow should we be expecting to come out? Not asking for it specifically, but like some partnerships, or we'll be getting some results from your blue sky properties. What other, are those right? And what other types of news should investors be expecting?
Yeah, of course, Martin. I mean, we got to be careful around material news, but I can just tell you what we've sort of sort of guided or indicated to the market. And basically, we're going to continue to drill at Baie-Jean-la-Marche. There's some drill results that are still pending there that should be out in the following weeks. We're going to continue to advance Lac-St-Jean into PEA. So you should see a PEA by the end of the year. We also working on our mineralogy at Lac-St-Jean, and we've also provided a bulk sample to Prayon. So just watch for some results on our purified phosphoric acid to come out. We are moving to a fully fledged beneficiation pilot plant that will take phosphate ore and turn it into phosphate concentrate. So watch for how that goes, I guess. And just watch general corporate developments. Yes, partnerships. There's ongoing discussions. And there's a lot of partners already at the table, right? So we need to expand some of the work with some of these, partners and associates that we already have at the table, and we need to expand it to new partners as well.
Excellent. Well, on that, let's wrap it up. John, thank you very much. I learned a lot from this presentation. That was informative. All right. Have a great day. Thank you.
Well, thank you, Martin. Thanks to you and to all of your viewers. We look forward to coming back again sometime soon.